Here we have to solve this one. This is a practical problem, okay? We'll see how to find the generator matrix. Yeah, the question starts from here. An end-state time homogeneous Markov jump process with transition probability matrix Pt over a period of length t is said to have a stationary distribution. If all the things are given, that's fine. We'll directly go to this one. In a particular company, the salary scale has only two different levels. On average, an employee spends 2 years at level 1 before moving on to the higher level. So the average time spending is given here, 2 years, okay? Or leaving the company. So after spending 2 years in a particular company, either he will get a promotion or he will leave the company. This is quite natural. I mean, mostly we have also seen it. An employee at the maximum level spends on an average 5 years before leaving the company. Highest level. Nobody is demoted, there is no demotion, and promotion can occur at any time. But the waiting time given 2 years and 5 years. 2 years in the initial level when someone will join. This, I mean, salary scale, in terms of salary scale, you can say level 1, and then in the next level, second level, the average spending time is 5 years. Upon leaving the level 1, the probability that an employee moves to level 2 is 50%. So suppose someone will leave level 1. So either, I mean, there is a 50-50 chance, either he will go to the next level, he will get a promotion on an average after 2 years, or he will leave the company, and the chances are given 50%. Derive the generator matrix of the Markov jump process. This is important. So we'll try to derive this one, then something more we need to do. Similar problems we have done for discrete time stochastic process. Okay. Now we'll do something for the continuous time stochastic process. We already solved one problem of this type. This is the second time, and with this one I will complete Markov process for the continuous time and homogeneous one. So let's write the generator matrix. So for that we need to write this one. Suppose this is 1, level 1, and this is level 2, promotion here, or according to the company, whenever you leave, this is suppose 3, okay, leaving company, you can write promotion, it's like normal level, okay. Suppose someone comes here, and then there is a 50% chance going here and here. What is the average spending time? Waiting time into 1, holding time we say. Suppose if I write this way, you can write here time 1, 2, 3, 2021, 22, 23, whatever you want you can write. You have to write 3 states here. Remember, this is a continuous time stochastic process. That means states will be here as well, and the transition can take place at any time, though the average spending time is 2 years. So holding time, someone will stay this way, hold this state, okay. When I say this is time 0 to 2, okay, 2 years staying in the level 1, okay. See, if someone will start here, one will stay up to this, will make a transition on an average, I am saying, here to this level or this level. Both possibilities are there, but it can happen at any time. Here also it can happen in continuous time. Suppose someone will start here, continue here, this is the holding time, or you can say occupancy probability, will occupy, the employee will occupy this and make a transition to some other state. It can take at any time. We are in continuous time stochastic process, but on an average one will occupy this level for 2 years before making a transition. And whenever the person will make a transition, he or she will not make a transition to one. Okay, there are two possibilities. One is he will get a promotion and he will stick to the same company. The other one is he will make a transition, he will leave the company. These are the two possibilities. Okay, so let me write the generator matrix here. Remember, this is not the transition matrix and we are not writing the probabilities, we are writing the transition intensities here. So the transition intensities, when you write, you have to know all the possibilities here. Okay, we know already all the possibilities, just you need to write it. So you have ways. Suppose I write level 1 here, 2 here, 3 here, 1 here, 2 here, 3 here. Now 1 to 1 and 1 to 2, 1 to 3. So I would like you to answer the jump chain matrix. Remember, we discussed last time capital Pij. Jump chain, when I say, once the employee will leave one, where he will go? That way. So you tell me the jump chain probability matrix. This is jump chain probability matrix. That means once the person will leave one, where it will go? Definitely it will be 0. Leaving 2 means we are taking this 0. Leaving 3 means we are taking this 0. Once the employee will leave 1, there is no direct way. If you remember, we solved a problem where there was a direct way, but here there is no direct way. This is 50%, this is 50%. And how we get the mu ij's? These are capital Pij's, and the formula is lambda I mu ij is equal to, Pij, that is mu ij. This is capital P, the jump chain probability matrix. Okay, so these are the probabilities. And how about 2 to 1? 2 to 1 is 0. If someone will leave 2, where the person will go from 2? You see here, from 2, highest level. Upon leaving 1 given, how about 2? An employee at maximum level spends on an average 5 years before leaving. That means there are only 2 levels in the company. Okay, so 2 to 3, there is no other way. How about 3? 3 to 3, anyway, 0. Then 3 to 2 is not possible. 3 to 1 is not possible. And then you multiply the average waiting time. Okay, here 2 years, I suppose, and we don't do anything about the diagonal matrix, forget about this. And for the non-diagonal entries, you have to multiply lambda 1 here. What is lambda 1 here? 50%, right? So lambda 1 is 0.5, lambda 2 is here 50%, here lambda 1, I think 2 years, right? 2 years and 5 years. So what is lambda 1? 1 by 2, right? What is the waiting time formula? If you remember, T Ti follows exponential lambda. Okay, this is the parameter. So this parameter you need to find, but 1 by lambdas are given. 1 by lambda 1, 1 by lambda 2 are given. So if you write this way, these are given 2 and 5. So lambda 1 will be 1 upon 2, lambda 2 will be 1 upon 5. You write this in terms of years if you want to find. Then to get mu ij's for the non-diagonal entries, if you remember, non-diagonal entries, will multiply lambda I and will find the mu ij's. Okay, so the mu ij's will be these. So here 0.5 you multiply by half, 1 upon 2, that will be 0.25. This will be 0.25. Then when you multiply 1 upon 5, okay, sorry, here 2 to 300%. So 1 upon 5, that is 0.20. This is 0. This is, sorry, this is not 0. This is a part of diagonal. We will find separately. Now these things we will find separately. Okay, diagonal. And this one will be minus of this plus this. So this will be minus 0.5, because if you add all, the sum of all the intensity should be 1, and here it will be minus 0.20. This is one way. Okay, this is one way you can find through this probability matrix. And remember, this is not the transition matrix for the discrete time. This is jump chain matrix. Okay, now if you want to find directly, remember I discussed directly also in the first class, this kind of a problem. You should be able to find all these directly as well in some cases, and in some cases this matrix will be given to you. Now you have to form Kolmogorov equation. You have to solve this one. Remember how to find directly? Okay, that you have to revise. You do it. Now let me write this one here only. This is our generator matrix. Zero, 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 I remember. And this was 0.25, this was 0.25, this was minus 0.5, 0, minus 0.20, 0.20, if I am not wrong. Next one will be this. This is over. Now it says the company currently has 1,000 employees. The proportions at levels 1 and 2 are 60% and 40% respectively. Assuming that nobody joins the company in the future, determine the distribution of these employees in 5 years' time. So the company is currently 1,000 employees given. Okay, 60%, 40% given. So if you want to write, there are two states actually. I mean the third one we use, that is for leaving. Okay, so currently, whatever date we can write here, thousand employees, so you can write 600, 400 here, this way. All are working in the company and nobody will join here. What will happen after 5 years? This is the question. Okay, assuming that nobody joins the company in the future, determine the distribution of these employees in 5 years' time. Now my question is, we have already solved these kind of problems in discrete time stochastic process. Remember here, 2001 to 2005, we have 5 years. Normally what we do in discrete time stochastic process, if the transition matrix is given, then if this is the yearly matrix, this is 1 year, 2 year, 3 year, 4 year, 5 year. What we do is we find P5, okay. Then we see in P5 the probabilities here, and you know the distribution here. So from, if this transition matrix is P here, then we multiply all and we find P5. But here no such transition matrix given. We are dealing in the continuous time, and everything is given in terms of mu here, right? These are mu's, these are not p's. This is generator matrix. So using the generator matrix, you can find this way, okay. Whatever way we started in class 1 and 2, we can do that way. Here you have to solve Kolmogorov's differential or integral equation. So we are doing differential equations now. Integral equations are not given in our material for homogeneous Markov processes. Integral equations are given only for non-homogeneous. Those equations we can use for homogeneous as well. So we'll do tomorrow non-homogeneous equation, and you will be able to know. Then you can apply that for homogeneous also, but directly not given, only forward equation and backward equation, that's all. So these are the mu's we know. From mu's you have to find Pij's, okay. So we have to form equations, not from the first principle but directly. We'll form equations and we'll solve equations. That is what we need to do. And this looks a very simple problem, but yeah, a lot of things we are supposed to do now. We'll start with one equation, okay, and then we'll solve it. Then we'll go to the next equation. Suppose, so what you are supposed to find, P11T, T will be 5, we'll put 5 here later, okay. So remember 1 to 1, if this is your state 1, this is 2, this is 3, 1, 2, 3, this way it was there, 2 to 3 was also there. These are the 3 states. Here P11, if you want to find, you need not use Kolmogorov's equation here, because P11 will be equal to P11 bar. Once you leave 1, there is no way you can come back to 1, okay. Suppose I am giving you a class, I am in this state. Once I leave this one, I will never come back and give you a class. If that kind of a thing is there, and someone sees me in the same state giving you a class after 15 minutes, that means it's bar only. P11, P11 bar equal. If there is no inward entry, if there is no inward entry to 1, then they will be equal all the time, okay. There is no inward entry to 1. So if I leave 1, I can never come back to 1. So here staying in 1 continuously and normally 1, 1, they are equal. So if they are equal, as I already mentioned you just before 15 minutes, if they are equal, then you need not use Kolmogorov's equation, forward equation, because there you need to apply the formula, you have to solve it, not required. Why not use directly that e power minus mu formula, okay. And when you write this one here, you have to see all those intensities, you have to know all those, they are going out. One is mu12, that is their 0.25, one is mu13, that is 0.25, you write that will be minus 0.5, okay. And then directly you can integrate minus 0.5, I am writing, it's like this, minus integration summation all mu ij's j is not equal to I, going out of this one, both are there. So we'll write, we'll add, this is 0.25, this is 0.25, this is 0.25. So you write here, that is 0.5 dt, you integrate, then you write 0.2 here, solve it. So we know P11T, Okay, let me write here P11T, that is equal to e power minus 0.5. Okay, so e power minus 0.5 t here, that is over. How about P22? So if I write P22 here, again there is no inward entry 22, so that will be equal to P22 bar. When you write P22 bar here, there is one arrow going out of 2, so it will not be 0 for sure, but you have to write 2 to 3. You check here 2 to 3, this is 2 and then this is 3.20. So you can write here 0.20, integrate and put limit, you will get t here. So e power minus is there, so e power minus 0.2 t. Okay, so at least we got P1122 directly. In this example, you will see in problems where inward entry is there, you have to apply Kolmogorov's forward equation or backward equation, whatever, whether they are equal or not. But the formula is there for bar, not for this one. Okay, and P33 will not find, it's 0, right? Even from 3 there is no outward entry, so if you apply this formula it will be 0, and 33 bar 0 anyway. So if you want you can write here P33 0. So I have a question, why we are finding all these things? If you didn't revise whatever I taught before, you need to find the transition matrix. Remember, you need to find the transition matrix from the generator. This is generator matrix, you are finding transition matrix, probabilities. These three we already got here. And all whatever required you are supposed to find. Okay, once you know this matrix, then in T you can put this T is there. So if you put value here for 5 years, you will directly get these answers. Okay, that will be the distribution. Distribution, when we say all 1 1 1 2 1 3 3 1 2 2 3 3, all transition matrix you need. Yes, I understand it takes a lot of time to do all the things. Even it was a part of CT4 50%. Now we have a lot of things to do. So it's quite heavy CS2 actually. Even according to me, it's heavier than CM2. Anyway, let's continue now. So Pij when I is equal to j, that part is over. The next part is, we'll find one when I is not equal to j. Suppose you pick up 1 2, d upon dt P12. This is the Kolmogorov's forward differential equation, and I will write P11 then mu 1 2 plus P12 see 1 to 2. Okay, 1 1 1 2 1 2 2 2. This is the equation directly, without using any such, using the formula I find this. Okay, not by general reasoning. Now we need to solve this one, and remember the same thing we are doing. It's very easy, but it requires time. But it's very difficult if you don't have time. Mu 1 2 2 2 there. See, all repetition. Mu 1 2 mu 2 there. We'll put here. Okay, then we'll solve it. And this one, if you want to form from the first principle, it will take some time, another 5 minutes. You have to start this way. P1 2, we write this way though, in life insurance case, x plus t 1 2, we have written that way. T2 x2 x plus t plus dt you have to find. So if you write this way, you have to find P1 to t plus dt you have to write. You have to find this way. Then you will get P1 to t here, bring that one, divide by dt, take limit tends to 0. Directly you will get this one. So what happens is, sometimes if you are unable to form differential equation directly, you can apply this technique as well. That will not only apply to these kind of problems, but these, any kind of problems in multiple state modeling you can always use. But directly formula is there and it never creates a problem to form this one. Now we need to solve this equation. Okay, to solve this equation, you need to put the values, either they will be given in the question or in the practical setting you need to estimate. You can only estimate in continuous time stochastic process mu's, not p's. That's why we solve Kolmogorov's differential equation. I already explained many times. So let's put the values here, whatever we have, then we'll solve it. Okay, so let me write d upon dt p1 to t, that is equal to, this was 0.25 p11 t plus p1 to t, this one is minus 0.20. Okay, next task is, when you solve a differential equation, remember we use linear differential equation. When you solve this differential equation, you have these two, the form is dy upon dx, okay, dt plus py is equal to q, where p and q are functions of t alone or constants. This is the normal form of a differential equation. Y dy is here, dy by dx. Here if you take this is y, this y is appearing here, so you will be able to solve, but this one you have to take away anyway. So now, as I already mentioned you before, there must be a link between this. Suppose you are at 1, okay, so when you leave 1, where you will go in time t? Either from 1 you go to 2 or you go to 3. So you must be able to write p11t. I am not talking about mu. This is by general reasoning also you can say. So what is p11t? P11t is equal to P11t will be equal to 1 minus P12t minus P1 1 to 1, 1 to 2, 1 to 3. These are the three ways, right? 1 to 3t, because total probability is 1. Now the problem here is, still we don't have this one. You are solving this one, this term will come, that's fine. Here if you replace this one by 1 minus this term will come, that's fine. This one is here, this one is here, this one is here. We'll be able to solve this kind of a differential equation. However, still there is 1 3. Okay, so to find 1 2 you need 1 3 also. How can you find 1 3 here? It's not given. Okay, that's the problem. If you find 1 2 here, you need 1 3. So you have to start with 1 3, d by dt p13t. Okay, if you want to find this one, there you will be needing p12. And in this kind of a situation, how you need to do? In most of the cases it will be easy. That's where we found directly this value. Remember? That's where we found this directly, this one. So instead of writing this one, in some problems we will write this way also, but every time it's not possible. Okay, so you can find this one either using same Kolmogorov's equation, or you can use this one, e power minus 0.5t. So we'll write this one here, p11t here, then it will be a perfectly linear form differential equation, first order, first degree linear differential equation. Okay, then we'll solve this one. So let me write this equation, d upon dt p12t, this was there, and then we have, oh sorry, point 0.25 this one plus P12T minus 0.2 this one will bring this side. Okay, so this will be dy upon dt minus 0.2y, that will be equal to 0.25, 1 by 4 I can write here, e power minus 0.5t. Okay, so integrating factor we find e power minus 0.2 dt, right? E power p dt we find, so it will be 0.2t. You have to multiply that one, or directly you can write e power 0.2t, that will be equal to y into integrating factor, that is equal to integration q integrating factor plus constant, that you need to write, and you have to solve this one. Okay, once you solve this one you will get this. Okay, I have written minus here. So e power 0.2t, this one we don't need anymore. Q is the right hand side, this q is the right hand side, will write, and IAP will multiply. Okay, e power 0.2t. So q you can write 0.25 minus 0.5t, and this one IAP is e power 0.2t. Okay, dt plus constant. Now here y value is there, we'll write it, y is p12t. Here p12t e2t, sorry 0.2t, that is equal to 0.25 is there, 1 by 4 let me write, and here this will be 2 minus 0.5. Okay, 0.2 minus 0.5, 0.2 is 1 by 5 minus 1 by 2, this is minus sign. Okay, 10 minus 3 upon 10, so e power minus 0.3t divided by minus 0.3 plus constant. Now we have to put limits here, or maybe we'll take this that side. Is equal to 0.3 upon 10 upon 3 you will get, so it will be minus 5 upon 6, right? E power minus 0.3t plus constant. Now we have to find the value of constant. To find that you take t0, okay, the boundary condition. If you take t0, e power 0 1, and here minus 5 upon 6 e power 0 1 plus c, so c is, this is 0, right? p1 to 0, there is no way you can go from 1 to 2 in 0 time, so c is 5 upon 6, so replace c by 5 upon 6. Then p1 to t will be e power 0.2t, it's plus or minus, I think minus, this side it will come. Okay, we'll bring later. That is equal to c is 5 upon 6, you take common, 1 minus e power minus 3t. Okay, so now you write the final one, 5 upon 6, if you take it here it will be e power minus 0.2t minus e power minus 0.5t. There is no constant here. Now see, we have p1 to t here. Okay, final answer will be, you check it, 600 1 to 2 5 plus 400 2 to 2 5. This is the answer. Okay, so 60% they are in the initial one and 4% there. So 2 to 2 how many will go, 1 to 2 how many will go in 5 years. That is what you have to find. So that will give you, if you find this one, that is that you will be able to know whatever it is that you need to find. So number of companies, so total 1000, we've started with 1000. Okay, and suppose you got this number into A, so you subtract this one, and how many will be there in 1 to 1. Okay, so you find this one also, P 1 to 1, 5 multiplied by 600. Okay, that one is B. So these are the numbers, whatever it is, they will leave the company.